Hi everybody. I see a lot of videos and topics in internet and on architecture discussions like API versus SDK and all other things. So let's talk about not the versus, but what's the API and SDK mean, how SDK could help to make your API better, and actually what the API and SDK actually is. Let's make one step back and just see the evolution of the software. Yeah. At the beginning, software was something that you create the set of instructions, run it once, and for every task you have the separate software. So it was no interaction with user at all. And it was job safetiness for the developers that every time when you need to enter some different things, you create a different program. But it's not so cool. So the next step that the people start creating the programs that actually have the interface. So the API, UI, GUI, and all other things, they have this magic letter E that mean the interface. So it's defined how you could interact with your program, and that's extremely simple. So if we're talking about the console interface, so it's the command line interface. It's one of the most oldest and one of the most popular user interface that you enter something from the console and it's your I/O system. And actually it is. So then GUI is just a user interface that user could interact with the program with a more human-friendly way. But what is actually the API and ABI? So I guess that ABI was way earlier than all other interfaces, and it's the first time when people discovered that the complexity of the systems is growing and growing, and now on one machine you don't have just one program that do something, but you have the operation system, for example, and some hardware devices. So you need the drivers, and you have a lot of programs, and it's the first time when programs needs to talk to each other. So it's not interaction of the user and program, it's interaction of the program to program. Yeah, it's quite interesting thing. And the first thing that your program could talk to another program, it's usually your operation system talk to or vice versa, your program talk to the operation system to do something. Yeah, so it's the drivers or the operation system interface. And first, these interfaces was the binary interfaces. So it's where the ABI came from. So it's application binary interface that design the communication. So all the application interfaces, in their majority, it's all about communication. It's how you talk with other program, how you involve the methods of other program, how you pass the parameters. And the binary interfaces are crucial for the operation system, and it's crucial for Web3 and contract development because you talk with the contracts as a ABI, so application binary interfaces. So you know how to pack all your parameters and all your method calls to some binary block that will be understood by the interface. So this binary was quite crucial because it's about performance and the data size and so on. But the problem was the application binary interfaces, that majority of them was designed by the developers of the app. It was some proprietary formats, it was not standard formats. So that's why people decide to do it slightly different and in a more generic way, even on the level of the your operation systems, together with ABI that is quite low level, or together with the contracts interfaces that are quite low level, they offer the application programmable interface. Yeah, so you extend your application in a way that other programs could use it and make them as a part of their own flow. So it's all about the API, so it's the programmable interfaces that program could be used by other program, It's not about REST endpoints or networks or JSON or whatever. It's the general term. So, and nowadays, it's the most popular way. It's the network interfaces where you could talk with the service across the wire and so on. And you describe how you could talk with your application, and it's much better when you do it in a standard way. That's why a majority of our modern application interfaces are network interfaces that use some standards for passing the data, for involving the methods. That's why we have HTTP, that's why we have the JSON. We still could have, for example, some binary formats that are generic. It's the proto buffers and gRPCs. But all of them have the simple idea that they allow you to call another program with some parameters. And it's quite common nowadays. Yeah, so the API is simple. Yeah, you define your interface to other programs that could interact with your program or with your system. So what the SDK and why we still need an SDK and how it's different from the API interface and why, for example, we have the SDK. So, for example, imagine that we have some API. It's a simple REST service that you send the picture of cat and gets back some information about the cat as a JSON format. It's simple, but it's required to, for example, prepare the request, know about the service location, know about some different environments and all other things, and it could be quite complex for the user. And usually it's SDK, it's not about one single service or one single network interface. You could have a lot of different services that have quite complex flows that interact with each other, and you want to hide this orchestration and complexity in a library and offer the simpler way to interact with your system or with your services. It's one case that it's a simplification of the complex flows. Another thing that the SDK allows to execute the code on the client side. So the SDK, the crucial difference between the API and SDK, that API is an interface to your program, and SDK it's the part of code that is an integral part of somebody else's program. So it's your code that gets embedded to somebody else's program, and when it's run on the client side, not on your side. And you need to be aware that with the API it's super simple. If you have a service, you change the service, you deploy, and voila, you control all the changes. With the SDK, you need to be aware that if SDK is a part of somebody else's program, if you release the new version of SDK, you need to notify people that folks, please upgrade the apps, and some apps could be already online and you have no control on it. So one of the crucial understanding and one of the crucial challenges of the SDK, that it's your code, that it's a part of somebody else's app that you have no way to control, you have no way to upgrade, and it could be quite challenging. You still could be smart and create the SDKs upgradable, that they keep the interface stable, but they could, for example, fetch the codes updates from the server. Yeah, and it's a quite tricky thing that you could upgrade your SDK on fly without upgrading the app. But it's the topic of the federated applications. I already have a video on my YouTube channel. So SDK, it's the code that run on the client side. It's allowed to simplify some things. It's allowed to lower the load on your own services because it's executed on the client side, as I already mentioned. But sometimes SDK is only one way to go if you want to make something only in a secured way on the edge of the device. For example, our SDK allow you to encrypt and securely store the verifiable credentials. So, and you don't share your private key with us, you not transmit your private key with any kind of our services. So it's the main reason why we have, for example, the SDK, because you own the private key. Then you have the special SDK that allows you to verify credentials, to sign credentials, to exchange the credentials, and how all this flows. So sometimes you have the code that do not require calling of the service, but require some computations like the cryptography operations or some other flow things. And it's only one way, just to create the SDK, and yeah, and then it's simple. It's allow you to do all these complex computations without involving any kind of services or clouds, and be on the safe side, be secured. And it's one of the reasons why you could have the SDK. It's crypto operations, security, oversimplification of the complex flows. So, what the downsides of the SDK comparing to the APIs? So I already mentioned that with API you have better control on the changes on your side. With the SDK, you usually have the challenge that the SDK written on some particular languages, and if you want to offer your SDK to the wider audience of the developers, then you need to recreate your SDK on the different languages. Yeah, for example, our SDK, it's TypeScript and JavaScript based, so it's open the huge amount of cross-platform development together with, for example, React Native browser apps, server-side apps, and so on. But still, it means that you need to have your program somehow written on the JavaScript ecosystem. If you want to do it in Java, maybe then you need to use our API interfaces. So what people usually do, first of all, the good language for the SDK usually dictated by the domain of the usage of your core domain. So if you do the mobile applications, maybe you could choose some other languages that is more popular in a mobile development and so on. But it's a couple of tricks how, for example, you could have cross language interfaces without need of rewriting everything multiple times on the different languages. For example, if you have C core or C++ SDK, you could use some projects like a Swing or some projects that could create you bindings for dynamic languages or different languages. So you have your core written in C and bunch of some smart proxy wrappers that used on some different languages. It's the one way. Another way is good old Java, but it's run everywhere, but you need to write your programs in Java. It's not what we want to achieve. Another quite experimental and cool way for the SDKs and how we could achieve using SDKs on the different with the different languages, it's the WebAssembly. And I believe that it's a future of extensively use of the WebAssembly in the libraries and SDKs in future, where you use your favorite language that you prefer, your team knows, you compile to the transferable architecture like WebAssembly, and then you have the tiny layer that create the bindings to your WebAssembly on the tons of other languages that other people prefer to use. So I believe that the future of the SDKs is more the federated, upgradable applications that will manipulate with the tiny and granular WebAssembly modules. I really believe in this approach, and I will experiment more on this space. We just covered the ABI, the API, and we covered our favorite SDK. Now we know the difference. For example, if you will take a look to the Amazon SDK, it's a set of quite granular, concrete services that have the tiny interfaces on the tons of key languages. So it's not generic. So they just rewrite the same interface on different languages. And yeah, experiment with our own Affinity SDK, give your feedback, let me know what you do in a SSI and VC space. So, and I hope that this video was useful. Just put the likes, write the comments. Do you have the SDK for your products? What kind of SDK you have? Do you have some hybrid solutions between the SDK and APIs? So I'm keen to hear more. So, and thank you for listening. Choose.